is equal to j, aij aij is equal to 0 when I is not equal to j, I is not equal to j, aij is 0, and aij is not equal to 0 when I is equal to j, then the matrix we can say as diagonal matrix. We can define a diagonal matrix in this way, or we can understand in this way: diag a1, a2, a3. In this way also we can express a diagonal matrix. In some question paper or in joint entrance also you can see this type of language. You have to understand if it is written diag a1, a2, a3, then you have to understand it's a 3 by 3 diagonal matrix. So in that case you can express this matrix in this way, that is a1 0 0 0 a2 0 0 0 a3. So in this way you can understand this language diagonal a1 a2 a3. In fact, in the assignment also you can get this type of questions, that add diag a1 a2 3 plus diag b1 b2 b3. So you can understand that you are asked to add two diagonal matrix. So once you understand that what is a diagonal matrix, next you have to understand scalar matrix. Basically these are all same, but conceptually they are something different. Now what is a scalar matrix? The scalar matrix are the diagonal matrix when all the diagonal elements along the primary diagonals must be same. That is scalar matrix. Scalar matrix. Here I can give one example. For example, 2 0 0 0 2 0 0 0 2. This is called a diagonal matrix when all the primary elements of this diagonal must be same. Then it is called scalar matrix. So basically from after learning diagonal matrix and scalar matrix, next we have to learn what is the unit matrix. That is actually our objective to come. So a unit matrix is also a square matrix and also a diagonal matrix and also a scalar matrix. So unit matrix, or we can say this as identity matrix. Identity matrix. The unit matrix or identity matrix can be defined when these primary diagonals are 1. What happens when a scalar matrix, the diagonal elements are 1, all are 1, then that scalar matrix you can say identity matrix. That is 1 0 0 0 1 0 0 0 1. This is a I3, that is 3 by 3 square 3 by 3 identity matrix. Similarly, a 2 by 2 identity matrix can be written as in this way: 1 0 0 1. These two are very very important. That's why I have defined both these type of identity matrix. I hope you have understood. The concept is clear. What is next time we will also discuss why we define this as identity matrix. This is a very conceptual name, identity matrix. We have to understand it conceptually why the name of this matrix is identity. Once we understand the product of the matrix, again we will come back and we will discuss about the significance of this name. Next is upper triangular matrix. So what is upper triangular matrix? Again, as I said, that we are classifying this matrix based on the primary diagonals. When the when the elements above the primary diagonals are non-zero, or you should say the elements below the primary diagonals are 0, then those matrix is called upper triangular matrix. That is above the primary diagonals, all the elements are non-zero. That's why its name is upper triangular matrix. All the upper elements are non-zero, but all the below elements of the primary diagonals are 0. That means if I want to give an example of upper triangular matrix, this is your 6, 7, 8, upper triangular matrix, that is 1, 2, 3, 4, 5, 6, and here I will write all these elements 0. That means it's a 3 by 3 upper triangular matrix where these elements are 0. These elements are 0 means what? These elements are 0 means the matrix when Aij is equal to 0, when I is more than j. This is you have to understand. I is more than j, and Aij is equal to, is not equal to 0 when I is equal to j, and Aij is not equal to 0 when I is less. This is a technical definition of the upper triangular matrix. Next is lower triangular matrix. If we understand the upper triangular matrix, we also understand the lower triangular matrix. What is lower triangular matrix? The lower triangular matrix is same thing when all the elements below the diagonals are non-zero, and above the diagonals, along with diagonals, all are 0. Then you can say lower triangular matrix. Example, if I say 1, 0, 0, say 4, 0, 6. With these primary diagonals, all the below elements are non-zero. Say 3, 5, 2. This is a lower triangular matrix. And technical definition of the lower triangular matrix, how can we understand? We can understand it if I say that Aij, here as I told you, the above the element I is always less than j. So Aij should be equal to 0 if I is less than j. Aij is not equal to 0 if it is always like this, and Aij is not equal to 0 if I is more than j. This is the definition of lower triangular matrix. Now once we understand the concept of this matrix, the last case which is generally coming in joint also, and is tracing of matrix or trace of matrix. What is the, generally in 2 more question, we can also give you this trace of matrix. Most of you forget the concept of trace of matrix. So what is trace of matrix? The last concept, trace of matrix. Trace of matrix. Trace of matrix. Generally, we define as find the TR of A. TR of A. The matrix is a TR of A. That is sum of the diagonals, sum of the elements of the primary diagonals is called the trace of the matrix. That is, if I say A1, the A2, A11, A12, A13, A21, A22, A23, A31, A32, A33. Here TR of A, I will write A11 plus A22 plus A33. This is called tracing of matrix. Tracing. That is, TR of A is nothing but sigma Aij when I is equal to j. This is very important. Tracing of matrix is to come or can also come in joint entrance. This is, and last but the least is submatrix. This is 11 classification, submatrix. Submatrix is what? What is submatrix? Submatrix means whenever we are deleting any one row or any column of a mother matrix and get another type of matrix, or if we delete both rows and columns, then also we can get the submatrix. For example, if the matrix is equal to, suppose 1, 2, 3, 4, 5, 6, 7, 8, then if I want to, if I delete this one, I can get this rectangular matrix. So this is a sub matrix which is we are getting from the given matrix. One important concept of sub matrix also can be said minor factor of this. So if I want to know, suppose if I want to delete the first row and first column, then you can get this one. This is called 4, 5, 7, 8. This is basically later on we will learn the cofactor minor factor of A11. One का जो minor factor, that is 4, 5, 7, 8. Very important concept. In this way, we can get total 9 minor factor, and those 9 minor factor matrix is very important, and that's why we are learning submatrix. Understand what is submatrix? If we delete any one row or any one column, for example, if I from here also, if I delete this column, I can get 5, 8. This is also an example of submatrix. And it's also a column matrix, right? So this is the submatrix, and last but the least is equality of matrix. Now equality of matrix means what? We can equalize, you can compare the two matrices like this. Suppose if I say a matrix is x, y, 2, 3, another matrix if I say 5, 6, 2, 3, that is here you see you can compare the row 2 for the first matrix and row 2 for the second matrix, they are same. So if we compare these two matrices, we can say that x is equal to 5 and y is equal to 6. This is actually we are getting the equality of matrix. This also we have learned in class 10 also. So I don't want to interfere more, just to reconnect you. As I told you, from here the question also can come. You may be given that solve x and y like this, x plus y 2, 3, and you are given say x minus 1, 1. This is 5, 2, 3. You may be asked that solve x and y. So in that case, you can in class 10 you just have to equalize. You should say that x minus 1 is equal to 1. You should say x plus y is equal to 5. Then solve these two equations and you can get x and y. So this is all about the types of matrix. So today we have learned the types of matrix. So next we will learn the operation of matrix, that I will send my video in my next class. Thank you very much. Today only you have learned types of matrix. सबसे important है, don't forget the trace of matrix, that is sum of the diagonal of the matrix of a square matrix is called the trace of matrix. Understand? We have also discussed about the unit matrix, that is also very important. That is what? That is when the scalar matrix the diagonals are 1. So based on the diagonal elements, we have basically classified all these square matrix, and those are very important concepts. Thank you very much, and listen my video regularly and give me feedback on how much you have understood. Thank you.